in order to work with this complex fraction, I'm going to go ahead and combine my numerator into one single fraction, my denominator into a single fraction, and then invert and multiply. So looking at my numerator, I have an LCD factor of x squared and y squared. So there's my LCD. I take my first fraction's numerator 1 times the missing LCD factor from its denominator. It has the x squared, it's missing the y squared. Minus my next fraction's numerator 1 times the LCD factors that are missing from its denominator. It has the x squared, or the y squared, it's missing the x squared. So I wind up with x squared minus, or y squared minus x squared over x squared y squared for my single fraction in the numerator. In the denominator, I'm going to do the same thing. I'm going to combine these into one single fraction. The least common denominator here is xy. I take my first fraction's numerator 1 times the missing LCD factor here, it's missing the y, plus the next fraction's numerator 1 times its missing LCD factor, it's missing the x. So when I look at this, my denominator winds up simplifying into the single fraction y plus x over xy. And once I get to this step, I can now invert and multiply. So my xy gets moved to the numerator, my y plus x to the denominator. In looking to simplify the resulting expression, I do have the difference of squares here. This is y plus x times y minus x. So the y plus x's cancel, and that we can also cancel these common factors. X cancels with one of these x's, y with one of the y's. And that leaves me with y minus x in the numerator, and in the denominator I have x, y. When I look at the restricted values, I see that I have to consider all canceled factors from the denominator as well as the uncanceled factors from the inverted numerator. So I don't have to worry about those. They've all been canceled, but I do have this y plus x. So I know that x can't equal the opposite of y. So this would be my solution. If I was rewriting this in standard form in alphabetical order, my negative x plus y over xy would be an alternate form, as well as factoring out the negative, getting x minus y all over xy. So these would be acceptable alternative forms as well.